Hey, South Carolina's Math and History, and we are going to be learning about reflecting a shape and finding the area. So, in geometry, what our school is going to do is they're going to give us a test where it has reflecting a shape. Then we have to find the area of that shape. So, let's use an example where we will reflect a shape. But hang on. When you think of the word reflecting, you might think of this.
Well, I am not gonna be eliminated. I've got my mirror. Ha!
Why is there a bush here?
It's so bright!
Yeah! Oh no, not here again.
That's exactly what reflecting is. Something that sort of bounces off or something that looks like the opposite direction. But we're not going to point a laser and we're not going to use any lasers in this video. What we're going to do is we're going to reflect a shape, which requires no electricity except this phone. Okay, so here are the coordinates on the graph that make up a rectangle. We are going to use the graph and put it into a binder because this is the part where we're going to reflect the shape and transfer it to the other side. This is the x-axis, the purple line. The y-axis cannot be put on here because the y-axis is literally this metal thing. And we're going to explain why that happens and how it happens. For now, on the graph, we're going to mark these and turn them onto points on a graph, like x and y. Let's say the first line from here is known as 1. And we're going to say the one on the other one, the first line right here, is going to pronounce as -1 for better measurements. Okay, so if we start here and go to see right here, we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going to say it's 12 as x and y as 0. Now there's a point on a graph. Now let's calculate d. So we started here at 12, horizontally, 13, 14, 15, 16, 17, 18. So d is now going to be 18, 0. Now, we're going to understand a and b as points. So if c was here and we counted 12 on the x-axis, the y-axis is up and down. So we're going to say 1, 2, 3, 4, 5. So we're going to say 12, 5. So 12, 5. And on B, we're going to say if D was 18, D is 1, 2, 3, 4, 5. Point B would be 18, 5. So now we have the points on a graph. We have A, B, C, and D. A, B have the same Y value, while C, D has the same Y value. We have B and D have the same X value, and we also have A and C as the X value. So we're going to say XY, we're going to say XY here, and also XY here. But last but not least, point D, X and Y. We're going to need this later. And the next step is the most exciting part. We get to reflect it over the y-axis. So we're going to copy down the 4 points, and we're going to see what it looks like. So now, if we reflect this thing over the y-axis, we'll be able to understand the coordinates of it and we'll also be able to understand what the math is. So understanding the points, we can say that point A will be here, point C will be here, point D will be here, and point B will be on the top right here. So without having to actually count from the y-axis, let's see what the coordinates are. So we moved from here, and we want to get to A prime, B prime, C prime, and D prime. The primes will tell you that it's been moved somehow, and it means it's the new point when we translate the geometric shapes. So A, it was 12, 5. Now, what we're going to do is we're going to now change it to negative 12, positive 5. The reason why it's that new point is when we reflect this thing over the y-axis, this is where it started, right here. But when we make our reflection, the opposite of the y would mean the change in x, not the change in y. For example, 12 was on the right side, but if you flip it over, negative 12 would be the opposite. The 5s are not going to change because those are the y values. When you switch the y-axis and reflect it, your y value is going to stay the same. Now let's try for number or point B. So we have 18.5. That's going to be turned into negative 18.5. The same rule happens with point A. We start from here, but your only thing that's going to change after you reflect is going to be the x-axis. The x-axis. Now, we can do C and D. C is, it's going to be negative 12, and it's going to be y as 0, unfortunately. And for D, it's going to be negative 18 and positive 0. Or I'm going to say 0 because 0 is a neutral number. So negative 18, 0. So now we have found the new points for our reflected shape. We moved from here. Yeah, we moved from right here. And we reflected it over the y-axis to right over here. Now the last thing we gotta do before this video ends is we gotta find the area of both of them. So to find the area of both of the rectangles, we have to find the area of just one, since these two are congruent because we have reflected them earlier. So let's count the lines. We go from here. Here's 1, 2, 3, 4, 5, 6. So this is going to be 6. Wow, 1, 2, 3, 4, 5. So 6 times 5 is going to be 30. The formula for finding a rectangle is going to be, our area is going to be the base times the height. So if we do 5 times 6, it's going to bring us an area of 60. No, it's going to bring us an area of not 60. That was a joke. An area of 30 units squared. But didn't we say we want to find the area of both of them all together? If this is the same measurement as this one right here, which is almost faded out, then we have to add 30 by itself 2 times. So our area instead is going to be 60 units squared, both together. So we have successfully reflected the shape from one side to the other side and also found the area of both of them together. I hope this video has helped you understand reflecting a shape and finding the area. Thank you for watching Tao Ping Analyze the Math Industry. Like and subscribe.